we recognize that there really are three technological disruptions that are happening right now that really do enable the reduction in cost and the acceleration of crop improvement timelines. First off, maybe a lot of us have heard about the decrease in DNA sequencing, the decrease in cost of DNA sequencing. It's the same technology for RNA sequencing. So the drop in cost of RNA sequencing has been precipitous. Yeah. And there's been concomitant improvements in things like measuring proteins, the changes to genetic genomes called epigenetics, the chemicals inside tissues called metabolites. Yeah. We really live in an era of unprecedented information about biological systems. Yes. We really can look into the tissues and understand, or at least measure, the state of those tissues. Second, we now have drones. We now have satellites covering every meter of the planet. We now have sensing equipment, on-farm equipment, on the edge, on-farm equipment. What does this mean? That's the second technological revolution is we live in an era of unprecedented information about our planet, the weather, the soil, etc. There's a challenge with swimming in unprecedented levels of information.
You've got all this genomics data, all this environmental data. How do you then make sense of it?
How do you make sense of it? Enter the third technological revolution that we are all living. Everybody feels it every day. AI. AI is especially good at integrating this disparate, heterogeneous data. You know, weather data is inches of rain, heating degree days. Genetic data is oftentimes the presence and absence of a mutation. RNA data is how much RNA is in the cell. These even have different units. They're not even the same. So to have a human go and try to figure out how to convert those to the same thing, how to integrate them, that has been a major effort over the last few decades. AI is custom built to learn that interaction, not to have a human try to tease it out. It's excellent at separating signal from noise. It's excellent at understanding very complex nonlinear processes. So these are the three things that when you put them together really enable a new agricultural system that is lower cost and faster timelines.
We think mini proteins are really excited, and I see proteins in general and small design proteins specifically at really sitting in a great space that's between, of course, chemical crop protection, 95% of the market, strong COGS, it works, it's consistent. Now they have their challenges, but they really mostly are on timeline. And biologicals that can be more complex, where we go out and we find an exciting organism in nature, maybe a mycorrhizal fungus, maybe some interesting bacteria. When you go all the way to an organismal solution, I think you find amazing things, because nature does amazing things, but turning that into a product can be really challenging. You've got a domestication problem. Nature often doesn't think a lot about cost of goods as it builds solutions. It really doesn't. Those mycorrhizal fungi are getting a free ride from their plant partners. Plants don't worry much about energy. They have the opposite problems. So proteins are a defined molecular entity, just like a chemical, but they have many of the benefits, both actual environmental benefits and regulatory advantages of a biological. And we think it's a great segment and a great opportunity.
Our molecular glues act catalytically, so one compound can degrade very many proteins, potentially reducing application rates by up to 100 times. So most ag chem products, and indeed most drugs, function by inhibiting a catalytic site, so an active site. So you can imagine that Pac-Man model with something in his mouth. Our approach is different. We target non-catalytic sites to degrade rather than inhibiting the protein. So we are able to overcome resistance to existing targets. We're able to drug the previously undruggable targets, such as transcription factors, scaffold proteins, unlocking a new toolbox for targets for the industry.
So at Polybee, we are building physical AI agents that turn unpredictable produce farms into data-driven factories. Now, for centuries, produce farming has been helplessly unpredictable. And our thesis is that the root cause of that is lack of visibility and control on farming operations. So our physical AI agent operates a fleet of autonomous drones that runs around the farm and scouts every single plant and gathers intelligence on it. We're performing multiple jobs for farmers, such as forecasting yield, scouting for stress, and where relevant, performing jobs even like pollination. So we've already proven time and again across multiple crops, varieties, regions, that if our recommendations are followed for harvest timing, growers can walk away with 10 to 15% higher yield.
So our proprietary breeding technology, what it does, it actually identifies where those genes and traits of interest there are. Most importantly, those ones that would be otherwise unavailable with current breeding tools, like for example, gene editing or just breeding. And what we do is we help breeders to be able to get access to those with our technology, and then make sure that they can convert them to the next generation. So we work in meiosis, and basically that's where genetic diversity happens. And we can make that happen in a targeted and precise way.
What we do is human weeding at the farm scale. Because we know today there's a lot of labor shortage. We also know that the current solutions got to the limit, resistance from the herbicides, erosion coming from tillage over time. But the people don't want to come and work anymore in the field, and they are the most important resource that we have. We're replicating this and making it easier to adopt, affordable to adopt at a scale. You're using precision in a way that you use AI for contextual analysis, but you do it to replicate the way an experienced farmer would analyze. An experienced farmer would say, all right, this is a good weed, Elysium for instance, I want to keep it. This is a wide leaves weed, I will cut it this way. This is a grass weed, I need to go deeper. So this is the real-time understanding and the real-time decision-making we're doing in the field. And then we're using robotic arms to actuate, so actually to do a hand hoeing. And they all work independently, so they have them stacked, but it's like playing the piano, so each will go by its own.